Hello everyone, what we're looking at here is the proof of concept positive and negative electrode plates for the HHO cell which we will be developing. The plates are separated by nylon washers, 4 nylon bolts putting them together. So there's a 0.8 millimeter air gap between the two plates. Will sort of come down so you can see that air gap all the way through. You can see the washers there. So there's your air gap. Okay, now we're not using stainless steel plates. I've actually developed some brand new cutting edge stuff here, which I will explain to you in a second. Just have a look at the cell a bit more. You can see here that I've got a stainless steel twisted wire here, 316, coming off of this plate. All it is a piece of stainless steel wire that's been twisted around into a loop onto itself and then just pressed against the surface of that plate by the nylon bolt head. On the other side we've done the same thing with the twisted loop, and we'll zoom in there and we'll try doing it back here. There we go. You can see it's twisted on itself and it's just pressed against that plate there with the nylon washer. I did have a play around with some stainless steel plates. We went with a perforated style, a solid plate, and another perforated style with a slightly larger hole diameter to get production, but not as much as what we would have liked. So I looked into developing my own plates. These plates are actually made out of carbon fibre, believe it or not. I've put them through certain processes which enable them to be conductive. So they do conduct electricity. They have a high resistance. The resistance varies depending on where you measure the resistance. Like if you measure it here and here, it'll be different to here and here and to here and here. But they do conduct electricity. Non-metallic, it's just plain old carbon fibre sheets, but I'll put them through special processes. So as you can see here, this is what we're looking at, just plain carbon fibre. This is the matting that you would use in the carbon fibre pre-preg. And this is not the exact matting that I've used in here, but same sort of stuff, just a different weave pattern. Now, although I can't tell you what I've done to these carbon fibre sheets before and after the manufacturing process, I can tell you that they are definitely not magnetic, even though they are conductive. I've got a couple of ring magnets here that I pulled out of a magnetron. Anyone who's pulled one apart knows how strong these things are. I'll put that on top of this plate here and it's not going to pick it up. As you can see, not picking it up. The stainless steel wire, not going to pick it up. Stainless steel plates, oh, that one's picked up, didn't it? Maybe that's not stainless. Anyway, not picking up the stainless, not picking up the stainless. I think these might actually be mild steel maybe or something. Who knows? But as you can see, it'll grab onto everything else. So I'll just turn that around. Again, not going to pick up the plates, sitting them down, pulling it up, not going anywhere. And there you go. So this is the new plate setup. Air gap, 2 plates, positive and negative. One wire here on that side, one wire here on that side. Let's set it up and test it out. It just so happens that I have 1.5 litres of natural spring water sitting here, and I also have a nice little bowl which my wife bought for some flowers, so I'm kindly borrowing that indefinitely for my experiments. As you can see, this is fresh water. The seal has not been broken. You can hear it click and watch it for yourself. I'll zoom in. There we go, broke the seal. Now we're going to put the water in. Oops. Now we're not going to use any electrolyte. We're going with the plain water, in true Stanley Myers fashion. Now we'll grab the plate cell. We will connect one end and the other end, and place the cell in the water, fully submerged. The reason I've got the stainless steel wires coming off of it is because the alligator clips were corroding like crazy and contaminating the water. So now we've got the cell in the water. We'll just dip that down a bit further if we can, and we can't. But anyway, it's underwater. We can see, we should be able to see the air gap. You can sort of just see through it there. Zoom in a bit better. There you go. You can see the air gap. Anyway, we'll turn the cell on. Our 12 volt power supply. Got it set to 12 volts here. Zoom action. 12 volts. On DC, and turning it on. Now let's just sit here and watch it produce. We have gas production in plain water. Obviously it's got to condition itself just like a stainless steel plate would need to. You can see bubbles not only coming out from between the plates, but bubbles are actually forming on the surface of the plates. We'll zoom into that, and over time you'll see the bubbles form. So we'll just sit here and watch this. Might go around to the side here, so you can just see the gas coming out. So we've got a decent little amount of gas. And remember, this is a proof of concept. We're not going to be using 12 volts to actually run this cell. We're going to be pumping about 20,000 volts through it, DC at high frequency. Yeah. I have actually put these plates under load at 15,000 volts. Haven't quite hit 20 yet, but I've put them under 15,000 volts AC at line frequency through a neon sign transformer They held up well. I just connected one wire from the transformer to the plate on the other end of the plate, straight to the load, and it carried the load quite well. Didn't mark the surface, no deterioration of the plate, still just as strong as a standard carbon fibre plate, sheet, whatever you want to call it. So we'll come back around here so that we can just get in a bit closer here. Zoom. You can see all the bubbles on the surface there. I find after a while when it's conditioned, the bubbles, because they're so fine, they actually tend to cloud the water. Because they're so light, they just bounce off the bubbles that have already formed on the surface and bounce back down into the water. Anyway, proof of concept proven. Yeah, we have gas. It does ignite. I'm not going to bother showing you because my garage door is down and it's been going for a little while now, and I don't want a massive fireball in here. So there you go. Carbon fibre. We'll be making more of these and larger ones. I've got enough to make enough carbon fibre to make a small car. So we'll be doing some more experiments with more plates. We're not going to be going with the whole, 7-plate assembly, trying to get to 2.2 volts between each plate and all that sort of stuff as per standard HHO. At 12 volts, it's all high voltage, low current, pulse DC at high frequency, low power. Thanks for watching.